Now, the other thing we need to be able to do with polynomials is that we need to be able to do operations with them. And what I mean by operations is that we need to be able to add, subtract, multiply, or divide accordingly in order to create new equations. Wherever we can, we also like to make sure we can factorize and simplify where necessary. So let's have a look at this first one here. So I've been told that, and I may as well give these all these separate colors. I've been told that f of x is equal to x cubed minus 2x squared plus x. I have been told here that g of x is equal to 2 minus 3x, and h of x here is equal to x squared plus x. So I need to simplify each of these following little friends. So the first one here, b, is equal to, we've been asked to add f of x to h of x. Oops. F of x to h of x. Now there's a number of ways you could do it. I'm just going to do a very conventional addition here. So x cubed minus 2x squared plus x. And I'm going to plop h of x underneath it at the appropriate column. X squared plus x. Add these two lovelies together. X cubed plus nothing is going to make that x cubed. Negative 2x squared plus an x squared is going to make that negative x squared. And if we've got an x plus an x, then that's going to get us equal to 2x. And hooray, we've added those together. Of course, we always like to make sure that we can simplify where possible. We want a golden response answer. So when I say simplify, what I mean is to be able to factorize. We like to have a good mathematician would like to express things as simply as possible. So what I'm going to do for my golden response answers, I'm going to factorize. I can see I can do a common factor of x's. So look at x squared minus x plus 2. Which is lovely. I managed to get a common factor out. Now, can I get that quadratic, that's the little friend inside the brackets, can I get that into anything simpler? Well, indeed I can. If I can think of two lovely brackets, I need two numbers that multiply together to get positive 2, add together to get negative 1. So two numbers that multiply together to get positive 2, add together to get negative 1. Well, that will have to be negative 2 and positive 1. And huzzah, there is my golden response answer. Of course, in this particular question, it hasn't told you specifically to factorize or to simplify accordingly, and in most instances, the unfactorized answer will be fine. However, if you want to challenge yourself to be able to express your answers in the most mathematically correct way, that is a phrase now, then we always try to go with the golden response answer. Let's have a look at our next friend here. So we've got f of x take away g of x. Well, here we go. We've got for c, f of x take away g of x. So again, I'm just going to line up accordingly. Going to do a big subtraction here. Now you see g of x, it actually has 2 minus 3x. So I'm going to put the negative 3x underneath this x here. And then I'm going to put the 2, which is a positive 2, just at the end here. What I'm going to do is I'm just going to subtract accordingly. So you'll notice here, I've just put a little 0 here just to line things up. So 0 take away positive 2, it's going to make that a negative 2. X minus 3x, 2 minuses make a plus, so that's going to make that a positive 4x. Negative 2x squared minus nothing is going to be negative 2x squared. X cubed take away nothing is going to be x cubed. So there is our final answer. For this particular friend here, which is for C here, there's nothing that you can do to simplify that, so that will have to remain to our answer. With G, I'm going to leave F for a moment. I may as well do all my addition ones at the moment. So G, I've got to add all of these friends together. Again, I'm just going to go with the simplest way, which is just to line them up on top of each other, just like I did before. So negative 3x plus 2, and then h of x down here is x squared plus x. And I'm just going to put some zeros just to fill up the gaps so I know what I'm doing. So 0 plus 2 plus 0 is going to make that a 2x plus minus 3x. So the plus and a minus is going to make that a minus. So it's negative 2x. plus x, it makes that negative x. And then we've got negative 2x squared plus an x squared. It's going to make that a negative x squared. And x cubed plus nothing, it's going to make that an x cubed. There we go. And then we've got our final answer there. And I should put a little plus sign because it's a positive 2. If you see a break in transmission like that, it's because I've noticed that I accidentally did something wrong and I had to cut it out. And also sometimes you might see me glance over this side. It's where I've got my solution, so I know I'm not leading you up the garden path. So now I'm looking at f. Ask for g of x times by h of x. So we're going to get 2 minus 3x, and h here is x squared plus x. So you notice here I've just put them in 2 brackets, and so what I'm going to do is multiply one thing after the other. So I'm going to go and multiply 2 times x, 2 times x squared, it's going to be 2x squared, and then we're going to get 2 times x, which is positive 2x, and then we're going to get negative 3x times by x squared, which is negative 3x cubed, and then negative 3x times by x, which is negative 3x squared. So now what we're going to do here is then we're now going to go and simplify this very lovely friend. So 2x squared, take away an x squared, is going to make that negative x squared. Well, in fact, we usually like to put the highest powered term at the front, so we'll make that negative 3x cubed, and then we'll 2x squared, take away 3x squared, is going to make that a negative x squared plus a 2x. And then what we can do is we can go and see if we can take something common out. We can take an x out. Oh, may as well take a negative x out because we'll get rid of this minus sign. So that's going to be 3x squared plus x minus 2. Now, can that be simplified into 2 brackets? Oh, well, would you believe it? If we use, I'll just put my little highlighting here. Just going to move this over here. I need to get 2 brackets. One of them will have a 3x, one of the others will have an x. Why is that? Because 3x times x will make that 3x squared. So I need to put 2 numbers here such that they multiply together to get negative 2. And when I put them all together here, then in this diagonal fashion, then it will equal to positive 1. So let's go and have a look here. If I put a positive 2, in fact, actually, we want to put the positive 1 there, put a negative 2 here. So 3x times by positive 1 is going to be 3x. X times negative 2 is going to be negative 2x. If I add these 2 lovelies together, 2x plus 3x, well, that's going to be equal to x. Perfect. It's exactly what I'm looking for. It's looking for the number in between. So this is negative x, 3x minus 2, x plus 1. There is our lovely gold standard answer. With h, we got f of x and h of x. So f of x times by h of x here, we're going to multiply these 2 friends together. So x cubed minus 2x squared plus x. And then we're going to go and find, what's the other one? H of x. And again, what I'm going to do is I'm going to multiply one thing after the other. So hopefully you'll be able to follow along. So we're going to multiply these 2. So x cubed times by x squared is x to the power of 5. X cubed times by x, well, that's going to be equal to x to the power of 4. Negative 2x squared times by x squared is going to be equal to negative 2x to the power of 4. Negative 2x squared times by x is equal to negative 2x to the power of 3. If you've forgotten, if you're watching that and going, but hang on, why does x cubed times by x squared equal to x to the power of 5. Sure, it's x to the power of 6. Well, no. Remember your index laws. If a to the power of b times by a to the power of c, it's going to be the same as a to the power of b plus c. It's just as a lovely reminder there. And then we've got x times by x squared is equal to x to the power of 3. X times by x is equal to x squared. So we'll tidy up this nonsense. There's no other x to the power of 5, so that lovely friend can sit at the front. X to the power of 4, take away 2x to the power of 4 is negative x to the power of 4. Negative 2x cubed plus an x cubed makes it negative x cubed, and we've got an x squared here. Now we can take a common factor out. Now, of course, in all the other examples, we took just an x out. Well, we actually notice we got this x squared here. We can actually divide everything out by x squared and get an even simpler answer. So I'm going to go and take a common factor of x squared out. Power of 3, x to the power of 2, x plus 1. So we're taking a common factor out. Now we've got this horrendous bit of cubic here. Now I can tell you that the gold standard answer for this actually is that lovingly factorizes into those. But how on earth did I do that? Well, you'll need to go and stay tuned for our dividing or factorizing cubics video, which is a little bit later on. But that would be the absolute gold standard answer there. So in the meantime, before we can factorize cubics, this would be a very lovely answer here. But otherwise, if you could at least take out a common factor of the x squared, that would also be dandy. But here is our lovely gold standard answer. Now, question 8 here is a blighter of a question because it's making it seem like it's something that you've never done before. You may have to do simultaneous equations and all that kind of nonsense. Well, I can assure you it's not. So it says here, let x squared plus 6x minus 2 equals brackets x minus b squared plus c. Find the values of b and c such that this is all true for all of x. Now, you could try to move things on one side, make it equal to 0, solve, and all that nonsense. That's just going to get you into trouble. Have a look at this equation here. It is a quadratic. That is a quadratic because the highest power term is a squared. And then this is still a squared here. However, hopefully you might notice this looks like a particular form of quadratic that we've dealt with before. This is in fact turning point form. So for all this question is actually asking, it's saying, could you kindly, ever so kindly, turn that quadratic into turning point form? That's what it's saying, even though it just looks incredibly difficult and strange and weird. So that's what we'll do for it. We shall, by doing so, we'll have to complete the square. So let's go and make sure we do that as well. So we're going to go x squared plus 6x minus 2. So that's, we need to complete the square. So you'll remember with completing the square, I have to add and subtract the middle term divided by 2 squared. From our previous lessons. And then that's going to be equal to 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. Minus 9. Minus 2. And then what I'm going to do is I'm going to take this lovely friend here, this quadratic here. And what I'm going to do is I'm going to find, I'll find the brackets, how I can factorize it into brackets. 2 numbers that multiply together to get 9, add together to get 6. Well, that's going to be 3 times 3 is 9. Add them together, it's going to be 6. So that will be the same as saying x plus 3 all squared. Minus 9 minus 11 is minus 2 equals negative 11. Sorry, it's minus 9 minus 2. So there we go. We've turned it into turning point form. So it says here, it needs to be in this form, x minus b squared plus c. Well, this will tell me that b is equal to negative 3. And c is equal to negative 11. Now, how, you see I've got a 3 here, a positive 3. Why have I said it's minus 3? Well, have a look at the top there. If I was to substitute b is equal to minus 3 up in there, because remember that's what this equation says here, then that would become x minus minus 3 squared plus minus 11, and that will be equal to x plus 3 squared minus 11. There we go, perfect. So that's all splendid and done. So that's why that had to be minus 3.